Again, November 2016, a question on calculus. The question is y is equal to e to the power x sin x. Find an expression for dy by dx. Okay, so I'll take out the question again. So, so y is equal to e to the power x sin x. Find dy by dx. So dy by dx means it is differentiation of this term. So there are two terms, two x terms. One is this x term and then one is another this x term. So let us call it as u into v. So which is we have to apply a product rule which says whenever you have to differentiate two functions, it is u into v dash plus v into u dash. So what does this mean? You have to keep the first function, differentiate the second function, keep the second function, differentiate the first function. So we are going to do that now. Keep, so dy by dx would be keep the first function as it is e to the power x, differentiate the second function which is cos x, plus keep the second function and differentiate the first function. Fine, this is the first part of the question. That's the answer. You can take out e to the power x and write cos x plus sin x. Okay. So next part, I'll take out the question. Now find d square y by dx square. D square y by dx square. You have to show that it is 2 to the power 2 e power x into cos x. So let's take this function. Let's take this one and differentiate this again. So dy by dx was e to the power x cos x plus sin x e power x. Okay, now again there are two terms. You have to do u into v two times here. So first one, keep the first function, differentiate the second function. Differentiation of e to cos x is minus sin x, plus keep the cos x function. Differentiation of e power x is e power x only. Plus for this again u into v rule. Keep sin x as it is. Differentiate e power x, which is e power x. Plus keep the second function e power x. Differentiation of cos sin x is cos x. Now see what terms can be cancelled. I can see this and this term can be cancelled. Now these two terms are same and we can write them as 2 times e power x into cos x, which is your second derivative, d square y dx square. Now next part of the question. The next part of the question says show that the function has local maximum when x equal to 3 pi by 4. Now to find the local maximum or local minimum, you have to take the first derivative, which is dy by dx, as equal to 0. That means whenever the curve is turning around here and here, the slopes will be equal to 0. That's why we'll take dy by dx as 0. So what was our dy by dx? Our dy by dx was this. We'll take them. It was e power x cos x plus e power x sin x. This entire thing is equal to 0. Okay, now can we take e power x common? E power x into cos x plus sin x equals to 0. Now e power x, either e power x is equal to 0 or cos x plus sin x equal to 0. Now e power x can never be 0. X can be any value, but any value cannot get a real value for x for this entire term to become 0. So e power x equal, it cannot be equal to 0. Now only this term has to be equal to 0. So cos x equals to minus sin x, or you take cos x on this side, so min 1 is equal, write it like this, 1 is equal to minus sin x divided by cos x, so which is minus tan x. Now tan x is negative, we all know that tan x is negative in this quadrant or in the this quadrant, the second quadrant or the fourth quadrant. Okay, so tan x equal to minus 1, so x is equal to either minus pi by 4 or 180 minus pi by 4, which is 3 pi by 4. Now is there any conditions there? Now we got two possible values of x. Now how do you figure out which is maximum and which is minimum? To figure out maximum or minimum, find the second derivative of x, dy by d square y by dx square. Now the second derivative, when you substitute the value of x, if it is greater than 0, it is minimum point. If this is less than 0, it will be a maximum point. The x coordinate, whichever you get, will be minimum if the second derivative after substitution of x is greater than 0. It is maximum when the second derivative after substitution of x will be lesser than 0. So let's take the second derivative function. We got the second derivative as this. We'll substitute that. So e power x into cos x 2 times was your second derivative, d square y by dx square. Now let us substitute both the values in this. So if you substitute 2 into e to the power minus pi by 4 into cos of minus pi by 4, what do you get? Cos of negative theta is positive cos theta. This e power negative can never be a, this will be a positive value only. This is also positive, this is also positive. So hence negative pi by 4 is positive. Second derivative is positive greater than 0. It means this point is minimum, local minimum. Let us substitute 3 pi by 4 and see once. 2 e power 3 pi by 4 into cos of 3 pi by 4. Now all students take coffee. So 3 pi by 4 is in the second quadrant. In the second quadrant, cos is negative. So you end up getting a negative value. So what does it mean? So negative value of this means it is the point is maximum. So at x equal to 3 pi by 4, the function is maximum. Next, let me take the next part of the question. Now find the point of inflection. What does the point of inflection means? The point of inflection means the second derivative is 0. D square y by dx square is equal to 0. At which point of x it is equal to 0, you have to figure out. So take out the second derivative function. So this term you take it and find the x coordinate. So 2 e power x cos x equals to 0. Now we know that this cannot be 0. E power x cannot be equal to 0 for any value of x. Now we are left with cos x is equal to 0. So this can happen at x equal to pi by 2, or only this possibility, x equal to pi by 2. Next part of the question. Now the graph of function clearly showing the local maximum, point of inflection, and the axis intercepts. Now this left to be 0, pi by 2, pi. Okay, now what did we get as local maximum value? It was at 3 pi by 4. So 3 pi by 4 is at uh, somewhere between these two, exactly between these two. This is the maximum. Okay, point of inflection we got it as pi by 2 here. We also got a minimum point. Where did we get minimum point? Minimum point was at minus pi by 4. So minus pi by 4 is here, pi by 2. This is minus pi by 4. At this positive, it was a minimum point. Now, does the curve cut x-axis can be uh, y is equal to e power x sine x, right? So y is equal to e power x sine x. Now this is equal to 0. If this is equal to 0, sine x has to be equal to 0. Sine x is 0 at 0 only. Okay, so the function passes through this point. So something like this, at the minimum is here, it will pass through this, it will keep going here, and it will turn on. This is the curve, this is the maximum point. Next part of the question. The area of the region enclosed, find the area of the region enclosed between the graph and x-axis. Now area enclosed on the region and x-axis. What does area under the region mean? So area under the region is always integration. Okay, from what point to what point are they asking? Let's look at that. So area under the region of f-axis, f the function, and x-axis.